Hello, my name is Min Song.
My name is Stacy Okai. We're both electrical engineering students at Christian Brothers University, and we're going to talk about our senior project, data logging with Go Baby Go.
Go Baby Go is a program founded by Dr. Cole Calloway that was started in 2012 at the University of Delaware. Go Baby Go aims to provide young children with limited mobility with the means to engage in everyday activities within society.
This is done by supplying the children with motorized ride-on cars, or MROCs. MROCs are basically electric toy cars that are modified for children with limited mobility. They are an alternative to expensive motorized chairs that many families are unable to afford.
The cars are modified to reduce acceleration. They have customized seatings to accommodate the specific needs of each child, and they have adaptable steering mechanisms.
The Go Baby Go Foundation aims to remove barriers for children with disabilities while improving the quality of life. The Go Baby Go Foundation and MROCs promote independence, skill development, and socialization.
To gain the most information about how children interact with the vehicle, our project involves developing and installing a data logger inside of the MROC as a current customization. The information recorded by the device will aid in further research.
So, what is a data logger? A data logger is a device that monitors and records changes in conditions over time. It accepts analog and digital pins and is controlled by a microcontroller. A data logger eliminates the need for manual documentation, provides accurate and efficient data, and is inexpensive.
For this project, the data logger will keep track of time, date, and the forward and backward motions for every time the MROC is being used. We come up with 3 different solutions, with 2 using the Arduino Uno and 1 using the Nano. After further analysis, we decided on which model to use for the current prototype.
So the first design uses an Arduino Uno and a data logger shield. Here's the shield and here's the Uno. The shield has a built-in RTC, or real-time clock, and an SD card holder. The header pins are soldered onto the data logger and fits inside of the Arduino Uno. Some benefits of this design is that it is easily connected to the Arduino, it takes up minimal space, and is user-friendly. A disadvantage of the design is the cost of setting up the data logger. All components are purchased separately, such as the soldering kit, the Arduino Uno, and stacking headers.
The second design also uses the Arduino Uno, but this model uses the DS3231 RTC module and an SD card module. The DS3231 also has a built-in RTC, but the SD card module is a separate part from the RTC module. This means that there will be additional wiring for the data logger itself. The DS3231 has a built-in power sense circuit that monitors the status of the VCC to detect power failure and automatically switches to the backup power supply. This is so that the main power supply is cut off, the current time and date will still be maintained. The DS3231 uses a 3.6 volt lithium cooling battery cell on the back. And a major disadvantage of this design is that there's additional wiring and it's difficult to move around.
So the last design consists of an Arduino Nano kit. The kit includes the Arduino Nano and the data logger shield. This shield is similar to the first design, except it doesn't need to be soldered, and the logger comes with all supplies needed. So rather than buying individual parts separately, you have everything you need. Components in the kit include the Nano USB cable, RTC battery, the BMP280 pressure sensor, additional jumper wires, and a micro SD card.
For the total cost of the 3 loggers, the Nano logger is the cheapest, starting at $46.28. Minus the breadboard and additional wires, the kit includes all the parts needed to build and test the device. In order to test the other data loggers that use the Uno, additional components were purchased separately, which results in the cost nearly doubling for the other 2 designs. Based on the cost analysis and the pros and cons of each logger, we chose to implement the Nano into the current prototype of the car. The Nano is the best option because this design is the least expensive, is feasible with setup taking less than an hour, and it is user-friendly. A test circuit using the Arduino Nano is made up of 2 LED diodes and 2 switches. There are 4 resistors, with 2 being 100 ohms resistors that are in series with the LED. The value of the 100 ohm was chosen based on the LED specifications. The other 2 resistors are 6.8 kilo ohms. They are used as pull-down resistors to eliminate the output from the pin being a floating pin. Because the Arduino has an internal pull-up resistor, utilizing the 6.8 kilo ohm resistors are optional. Using the C++ programming language, the data logger is programmed to record the date and the time when the MRC is in motion. The information is stored on a micro SD card and can be read in a text file. The information can later be transported to Excel for further analysis. There are 4 cases of the switch and LED combinations that simulate the motion of the car. This is a test circuit of the MROC. Switches are used to turn the LEDs on and off in a simulating motion. One switch is made using 2 jumper wires that open and close the switch, and the other uses the push button. This is the data that's gathered so far, and when the switch is on,
So when the red LED is on and the green LED is off, it prints to the serial monitor that the car is moving forward. When the red LED is off and the green LED is on, it prints to the serial monitor the date and time that the car is moving backwards. If both LEDs are off, just as you see here, it prints to the monitor that the engine is off and the car is not moving. So if we turn the green LED back on and the red LED back on, it prints to the serial monitor that the engine is on and the car is not moving. So the car could be stopped. Now the information is stored to the micro SD card, and you simply take it out of the Nano, put it inside of the adapter, plug it into there, and everything is stored to a text file on the SD card. Alright, so here's our text file, and these are the cases that printed over. This is the column that printed the date, the time, and the case, and you see from here to here it's going forward, from here to there the engine was off and it wasn't moving. Here's the backwards case we had, and here is the other 2 cases where the lights were, both lights were either on or off and the vehicle wasn't moving. And that concludes our demonstration.
Working on a community-engaged senior project has been a wonderful experience and allowed us to learn in a professional environment while contributing to the quality of lives for many young children. We are grateful for the opportunity to support the powerful mission of removing barriers for children with limited mobility in our community and our society. Go Baby Go has impacted many lives, and we want to continue to bring more awareness to this cause and encourage others to join us in our project journey.
Yes, and we would like to thank Dr. Ventura, Patrick McGinnis, Noah Vongpit, Stephanie Lancaster, Kono Single at UT for their contribution to this project and encouragement. This has been an overview of data logging with Go Baby Go. Thank you for your time.